Hello and welcome to a little bit of paper practice with quadrilateral calculations. So we're seeing a lot of measurements on these quadrilaterals and we're going to have to sort our way through them. So let's start with these first ones. These first ones are just name the shape. So what we're going to do is kind of go through and highlight some things that we notice are the same. So for example, I noticed that these two are the same, and that these two are the same, and these two are the same. So I have all of these things that are kind of the same across from each other, such that they could fold over. And the only shape that does that where it folds in one direction but not the other is a kite. And you might have even just guessed that. It looks like a kite, what we call a kite in real life. It is, in fact, technically a kite. All right, now for this next one, I don't see anything the same. So you could assume maybe it's just a quadrilateral, but it does kind of look like there's a U-turn. And whenever we see a U-turn or two angles that add up to 180, that means we're going to have parallel lines. So those two lines are parallel, and when you have one pair of parallel lines, not two, but just one, we call that a trapezoid. Now this next one is, almost deceptively the exact same, because just like we had before where you got two angles that add up to 180 or two angles that add up to 180, we're going to have that again. And it's so clever in that it almost seems the same, where you got two angles that add up to 180, making parallel lines. However, this one has something a little bit more. It also has this symmetry where it could fold. And anytime something could fold, one of the ways that we describe that is isosceles. So this one is a trapezoid, but it's also an isosceles trapezoid because it has that symmetry that it could fold. All right, this next one is new. It's a little bit different. I noticed that I have a bunch of opposite things. So 10.8, 10.8, 15.2, 15.2. Angles are opposite, 70, 70, 110, 110. Everything's opposite. When you have that relationship where all the opposite things are equal, and you don't have any right angles, so there's no right angles, and all opposite things equal, that's a parallelogram. Parallelogram. That means that these lines are going to be parallel, and we could notice that because we have things that add up to 180. Those two add up to 180. Similarly, you can see that these two angles also add up to 180. When you have 180 U-turns in both directions, that's another way to reason into a parallelogram. All right, this next one, it looks like a parallelogram. It's like a parallelogram, but that's not the end of it. It is a parallelogram, but we're asked to be as specific as possible. So it's like a parallelogram, but because we have a bunch of things equal all the way around, all four sides are equal, that means it's going to be a rhombus. A rhombus is like the kite version of a parallelogram because you could fold it like a kite. And this is what a lot of people in early grades might have called like the diamond shape. If you feel, a little callback to your past and you say, that looks like that diamond tile that I use to put things together in pictures, that is a rhombus. All right, this next one is one of the earliest shapes that we ever learn. You see it very early on. And its key feature are these 4 right angles, and the sides are not equal. You could say like your base is different from your height. So I got 4 right angles, not equal. That is a rectangle. Not equal sides, is what I meant. If the sides were also equal, then it would be like the king of all shapes, the square, because the square fits every single property. Okay, now what we're going to focus on is these inside angles. There's no apparent exact relationship, but we do know that 4 angles in a quadrilateral sum to 360. You might be wondering, why is it 360? Well, it's kind of because it's 2 triangles. So we'd have 180 from this half and 180 from the other half. But if you put those 2 together, those interior angles total to 360. So that means I'm going to have 6 plus 10x plus 9x plus 10. So I got those 2 things, plus 108 plus 65. Those are all my things. And those are going to equal to 360. Now I've taken up quite a bit of space. So what I'm probably going to do here is kind of just jam in there equals 360. But we'll start combining like terms to lower some of our spaces. So I notice that I can have this 10x and 9x becomes 19x. And then my 6, 10, and 108 and 65, that's a lot going on there. Excuse me. Let's see if we can put them all together. So the 10, 108, and 65, that side is going to be 173, 183. But then we also have the 6 added to that, and that will give me 189. So 19x plus 189 equals 360. Let's go ahead and subtract 189. That's going to give me 171 over here equals 19x over there. Whew. And I have a feeling this might be like 8 times 9, but 8 times 19, but I'm not 100% sure. Let's see. 8 times 20 would be 160. So maybe it's 9 times 9. I think it is 9 times 19. Let's try 9 times 19. 9 times 10 would give me 90, and 9 times 9 would give me 81. And what do you know? That's 171. So x equals 9. But here's the catch. That's not what the actual question was. The actual question was find the measure of angle V, which happens to be here, 9x plus 10. And I know that x equals 9. So I have to do 9 times 9 plus 10 equals angle V. Or 81 plus 10 equals angle V. Or 91 equals angle V. And that looks pretty accurate because 91 is very close to a right angle. That looks very close to a right angle. All right, let's do the same thing over here. We're going to take the 4 angles, add them up, and then we're going to set that total sum equal to 360. Now I can combine some like terms. So I have my 10x, my 15x. Those will combine to 25x. Then for the other ones, I have a plus 1, a minus 4, plus 118, and a plus 70. Let's do that in a couple of stages. How about 118 minus 4 is going to be 114, And 70 plus 1 is 71. Then I can add those two together, and that would become a 5 for the ones, an 8 for the 10, so 80, 185 plus 25x equals 360. Again, I'm just trying to get x by itself so I can figure out what that is. I have 25x after I subtract 185 from both sides. And that would give me 175. Now, if I divide this by 25, I can start thinking of like dollars and quarters here. And 25 divided by 25 is just x, 1x. The other side, it would be like 7 quarters. So that's 7, $1.75. X equals 7. Am I done? No, because measure of angle E is 10x minus 4. So angle E equals 10 times 7 minus 4, which is 70 minus 4, which is 66. So angle E equals 66. Those were a little bit of the longer problems out of all these. Some of these are going to be somewhat shorter. But there's a lot of like indirect solving here. So for example, each of these next ones are going to be parallelograms. Does it say that they are? It doesn't say that they are, but these are parallelograms here. So what I can assume is that this angle 12x plus 5 and 10x plus 15, that those are equal. So I can say 10x plus 15 is equal to 12x minus 5. Because in a parallelogram, opposite angles are equal. Now I have an algebra equation to solve. I can add 5 to both sides, and I could subtract 10x to both sides. Let's see what that does. Gives me a 0. 15 and 5 makes 20. 12x and minus 10x is 2x. And 5 and minus 5 is a 0. And then what you can do is get x by itself, divide both sides by 2, and you'd have 10 equals x. But not done, not done. There's still more to do. We have to find angle F. That's this one here. So I still have kind of like a couple of layers to go here. I got to plug x into one of these and then use that information to find angle F. Well, 10 times 10 plus 15 is going to give me angle E. And that is 100 plus 15, or 115. And then angle F is going to equal the supplement, or the number that would add up to 180. So I'm going to subtract 115 from 180. And that gives me 65. So what's angle F? It's 65. All right. Now for number 10, I'm going to set it up, but I'm going to leave it to you to solve and then plug x back in to get the value that you need. So you're trying to find angle x, but we also have to find the value of x before we can do that. Now the three angles that are happening here are these three angles there. There's more than one way you can look at this, but essentially these three angles are making a U-turn and they add up to 180. It's hard to tell that this 4x plus 13 is talking about that top corner, but that is what's going on. So the setup here is 5x plus 12 plus 83 plus 4x plus 13 equals 180. You're going to get this down, solve for x. Then you're going to plug that x back into the angle capital X to get that number. And that'll be your finishing there. All right, we're going to try a few more here, kind of moving forward a little bit, mostly for time's sake. Let's see what we have. All right, on a trapezoid like this, I see a U-turn. And when we have a U-turn around parallel lines, things add up to 180. That tells me that 15x minus 20 plus 13x minus 24 equals 180. We'll go ahead and solve this one and the next one as well. I see some like terms. So we have this 15x and 13x. And we can combine those to make 28x. Then we'll do the minus 20 and the minus 24. Combine those, and that would become minus 44. And still going to total to 180. So again, just trying to get x by itself. And then we'll have 28x, and on the other side, 224. So when I divide this, 28x, or not divide by 28x, but divide by 28 on both sides, we're going to see that x equals, how much would that be? Probably, I don't know, honestly, 10 times 28. 10 times 28 would be 280, so that's much. So I think it's going to be 8, and it's kind of a little bit of guessing, but a little bit of something else. So if I do 8 times 28, 8 times 20 is going to be 160, and then 8 times 8 is 64. And what do you know? That is 224. So x does equal 8, but what's the question? Find angle K. So I have to do 15 times 8 minus 20. That's the same as 4 times 30, or 120 minus 20, which is 100. Okay, this next one's a little bit different. It says find measure of angle J, which is here. I would honestly say this one is easier. Notice that this has a trapezoid, but it's isosceles, like it's got these two sides that are equal. That tells me that also these two angles are equal. So this is a shorter equation. I have 9x plus 8 equals 12x minus 16. Then I just have a bunch of algebra to do. So let's see, I'm going to do minus 8. Actually, let's do it the other way. Let's do plus 16 minus 9x minus 9x. That would give me 24 on the left and 3x on the right. These numbers are much smaller, a little bit more friendly. I can do this more like a mental math. Divide by 3 on both sides, I get 8 equals x. But that's not the finish. That's only part of it. I got to plug that x in back here. 9 times 8 plus 8, which means it's 72 plus 8, or 80. And guess what? This other one's also 80, just for fun. All right, we are almost done we're near the end, and then at the bottom of this, you guys will see like an answer key if you want to go back and check answers, but I do expect some work to be done with it as well. All right, so for this one, we have a rhombus. And a rhombus can be described in a lot of ways. The way that's probably helpful here is a rhombus can also be described as two isosceles triangles. And I can see, like, even if I didn't have this bottom piece at all, I could still solve this problem because this is an isosceles triangle. That means that angle C in this corner is equal to angle A in that corner. So I could say that angle C plus angle A, let's try that again with some highlight, angle A plus 9x plus 3, 9x minus 3, that those three angles inside a triangle add up to 180. Now, angle C is 7x plus 11. And they're like, I don't know what angle A is. It's the same as angle C, so I just duplicate it, 7x plus 11. So now I have a 7x, 7x, and a 9x. Those three combined are 14 plus 9, or 23x. Then the 11, 11, and minus 3 would be 22 minus 3, or 19. So that's going to be plus 19 equals 180. So we got some less common numbers again. I'll subtract 19 from both sides. Gives me 23x equals, on the other side, 161. And if we divide these, pretty sure that x equals 7. And then I'm going to take that information and plug it back into x. I'll have 7 times 7 plus 11, or 49 plus 11. And that gives me 60. So angle C is 60. And it was asking for angle ACD. That's actually the one that we just found. We could have said this other side was 60, and go figure that it looks like the other one is 60 as well. This happened to be an equilateral triangle. That was just a coincidence. This again on number 14 is a rhombus. And in a rhombus, sides are equal. So another short equation because we just have two pieces that are equal. If we do some simplifying here, we got like plus 1 minus 15x minus 15x. That'll give me 2x equals 2, or x equals 1. But the thing it's asking me to find is one of these sides. Well, I can plug this 1 into anything, and it'll give me that side. So, because all the sides are the same. 15 times 1 plus 1 equals 16. All four sides are 16. All right, now we have some things with some symmetry going on. For each of these, I'm going to set it up, but ask you to kind of finish by plugging it in and finding some of the other information. This is a rhombus. And in a rhombus, we have a lot of symmetry. One of the things that we can say is it could rotate or reflect. And because it could rotate, those two angles are equal. So we would have 4x minus 6 equals 2x plus 12. You would solve for x equals something. And then you're going to plug that in into the angle it's asking for, which is BCA, or this angle here. Let's highlight it just to be clear. That angle is BCA. So you find x, plug it in, and then you'll get it. Something similar going on here. We have opposite angles, and opposite angles, there's so much symmetry in a rhombus. Opposite angles are equal. So I can say 13x minus 5 equals 12x plus 4. Work that down until you get to x equals something. Then you're going to plug it in to the angle it's asking for. Angle W is what you need to find. Okay, these last two. I will try to complete these ones fully. So we have Vx equals x plus 14. Xt equals 2x plus 6. On parallelograms and rhombuses and some other things as well, but any parallelogram, these two halves are going to be equal. They're two equal halves because they get bisected. That tells me that 2x plus 6 equals x plus 14. If I were to work my way to get x by itself, I would see that x equals 8. That can help me plug it into one of these sides. Like, for example, I could plug it in right there and get 8 plus 14 is equal to 22. So this side is 22, so is this side. The question it's asking me is the full length all the way across. So I'd have to add those together and get 22 plus 22 equals 44. This next one is very close, but has a slight difference to it. It tells us that our XR down here is 13 plus 2x for this side. And then the top side is x plus 13. So again, we have two equal bisected pieces there. We could say x plus 13 equals 13 plus 2x. This is where it does get a little weird. Watch what happens here. If I subtract x, subtract 13, I'm going to get something that feels like it shouldn't be correct. 0 equals x. Well, that's still correct, because if I were to plug in 0, then this top one would be 13, and the bottom one would be 13. So they're both 13. It's asking me to find XR, so we could just say, well, XR is 13. All right, that's the video for this. This should be posted so you guys can use it as a walkthrough. You need to get at least about half to 2/3 of this complete for full credit. Thank you.